Hello, today we are going to understand a topic which is part of integration, how to integrate expressions in the form of ax plus b to the power n. As we know, integration is just the reverse of differentiation, or what we say is kind of anti-differentiation. So to understand what would be our general formula when we integrate something which is in the form of ax plus b to the power n with respect to dx. To understand this part, let's connect this with differentiation first. Okay, now we know we know if we have some expressions such as 2x plus 1 to the power 6. So if we want to differentiate this function with respect to x, what would be its differentiation? So we'll consider a chain rule over here. So what does chain rule states? That first you have to differentiate the outer boundary, then we have to differentiate the inner boundary. So over here, what is our outer boundary is this bracket to the power 6, or we can say the power rule. So first we are going to apply power rule, so which results 6 2x plus 1 and 6 minus 1, that is 5. Now once we have differentiated the outer boundary, now we are going to differentiate the inner part of this. Now what is the inner part? Which is a linear expression, that is 2x plus 1. Now differentiation of 2x plus 1 is 2. It's okay. Now we know as integration is a different anti-differentiation, or what we say the reverse process of differentiation. Now if we integrate this expression with respect to dx, we should get the same value. Now in integration also we know this concept x to the power n. If we have something x to the power n, and if we integrate that with respect to x, what is our value? X to the power n plus 1 whole divided by n plus 1 plus c. Okay, let's apply this logic over here. What we get is, if we integrate this expressions, this whole expression over here, this is the whole expression. If we integrate, so what we will get, 6 and 2 are constant, so we can keep them outside, that is 6 into 2 is 12. Now this 2x plus 1 to the power 2x plus 1 to the power 5 plus 1, which is 6 whole divided by 6. Now are these two expressions same over here? No. Now if you simplify this, this is 6 times 1, this is 6 times 2. So what is the final expression we are getting is 2 times of 2x plus 1 to the power 6. So we are getting an extra 2 over here. Now why we are getting this extra 2? We should get this function when we are integrating, because when we differentiated this function, this is what we got. Now if we integrate this whole, we should get this part. Now the same idea over here is just like what we used to do in this 2x plus 1 to the power 6. What was the first step we did? We differentiated the outer boundary. Okay, that is 6 2x plus 1 and 6 minus 1. Okay, now what we did over here is, now we applied the chain rule over here. Now we differentiated the inside function and we multiplied it by 2. Okay, now in the process of now if we have this 6 2x plus 1 to the power 5 into 2. Now when we integrate this part, what we'll do is 2 6 into 2, we are keeping it aside. Now this is our function. If we integrate, this would be 2x plus 1 5 plus 1 whole divided by 5 plus 1. Okay, now as how we got this 2 over here? When we differentiated this part and we multiplied it over here, and we know integration is a reverse process. Now again what you will get over here is, when you differentiate this part, you will get 2. So instead of multiplying 2, in this case what we'll do is, reverse of that would be we'll divide it by 2. Now let's check what we will get. Now this 2 and 2 cancel, 5 plus 1 is 6, 5 plus 1. Okay, 6 cancel out. What we are getting? 2x plus 1 to the power 6, which is the same expression. But yeah, remember, whenever we are integrating, in case of indefinite integral, there would be plus constant c, which is very equally important over here. Okay, so now how can we generalize this rule? If you want to generalize this rule, so what we can say, if n is not equals to -1, first condition, and a is not equals to 0, okay, then if we are integrating, which is a linear functions, that is ax to the power n, integration of this with respect to dx would be ax plus b to the power n plus 1 whole divided by n plus 1. Now remember what we used to do in differentiation using the chain rule. We used to differentiate the inside part also. Now if you differentiate this inside part, what you will get is a. Now in case of differentiation, we used to multiply it by a. In this case, we'll divide it by a plus c. So if you simplify, I can write it down this as 1 upon a n plus 1. Now this is ax plus b to the power n plus 1 plus c. Is it clear? Okay. Now let's look at some examples over here. Now it's very important to note that this rule only works for powers of linear function. Is it clear? Okay. Now let's try to solve this example. That is integration 2x minus 3 to the power 4 dx. Okay, so integration of this would be, we'll apply power rule, that is we'll consider this whole as one function. So 2x minus 3, that is 4 plus 1 and upon 4 plus 1. Now when we used to differentiate this inside function, linear function, what would be differentiation of this linear function? 2. So instead of multiplying it by 2, we'll divide it by 2. So what is the final result? That is 2x minus 3 to the power 5. This is 4 plus 1, 5, 5 into 2, 10 plus c. So this is integration of this. Okay, let's check this part. Now if I differentiate this, I should get this value. Okay, let's differentiate this function, that is 2x minus 3 to the power 5 upon 10 plus c. Now if you differentiate this with respect to x, we'll get, first this is constant 1 by 10, we'll keep it aside. Now differentiation of this would be 5 times 2x minus 3 into 2, applying the chain rule. Now differentiation of a constant function is 0. Now this is 5. Okay, over here this would be 4, 1 power gets reduced. Now this is 5 times 2, 10. Now I can cancel out this 10 over here. So what is the value we are getting? 2x minus 3 to the power 4, which is same as this part. Okay, now let's look at one more example. Let's suppose if we have something similar to this, 20 divided by 1 minus 4x to the power 6 dx. Okay, now how to integrate this part? What we'll do is, we'll first take this whole, I can rewrite this as 20 times 1 minus 4x to the power negative 6 dx. Okay, now 20 is constant, I can keep it outside. Now integration of this would be 1 minus 4x. Now this is negative 6 plus 1 whole divided by negative 6 plus 1. Now what would be differentiation of this inside function? That would be negative 4. Now instead of multiplying it by negative 4 in integration, what we'll do is we'll divide it by negative 4 plus c. Now let's simplify this part. What we'll get is 21 minus 4x to the power negative 5. Now over here we'll get negative 5. This is negative 4. Negative 5 into negative 4 would be positive 20 plus c. Now this 20 and 20 gets cancelled out. So we are left with, I can rewrite this as 1 upon 1 minus 4x to the power 5 plus c. Okay, now let's suppose if you want to check our working, what we can do is we can differentiate this function with respect to x. So I can rewrite this as 1 minus 4x to the power negative 5 plus c. Now if you differentiate this part, what you'll get is negative 5 power root in multiplied 1 minus 4x negative 5 minus 1. Okay, now we'll do inside bracket differentiation. Differentiation of this would be negative 4. So in case of differentiation, we'll multiply, and differentiation of constant is 0. Okay, now let's simplify. Negative 5 into negative 4 would be 20. 1 minus 4x to the power negative 6, which we can write down as 20 upon 1 minus 4x to the power 6, which is similar to what we started with, 20 upon 1 minus 4x to the power 6. 20 upon 1 minus 4x to the power 6. Clear? I hope you are clear with this idea. Okay, let's do a last example on this part to have our understanding clear on this. I have taken different varieties of examples over here. Now let's suppose we are taking something where the power is in fractional form. I have taken different varieties of example which are in the form of ax plus b to the power n. We have seen different types of expressions, linear expressions with different powers, so that we have better understanding of this concept and we can apply this concept while solving the questions on the same. Okay, for our simplification purpose, I can write down this whole in the form of exponent. I can write it down as 2x plus 7 to the power negative half with respect to x. Why I have written negative half? So whenever we change the sign of a radical, this is a square root, I can write it down as half. Now since this whole expression was in denominator, I am writing down as in numerator, so I have written negative half, because we know x to the power negative 1 is 1 upon x. So it's just the reverse of that. Whenever you take a denominator in the numerator part, power is in negative. Okay. Now let's integrate this function with respect to x. What we'll get is 5 is a constant, we can keep it outside. Now integration of this would be 2x plus 7 negative half plus 1 whole divided by negative half plus 1. Now this outer part is done. Now inner part, differentiate this part. What we'll get over here is 2. Now instead of multiplying, I will divide it by 2 plus c. Okay, now let's simplify this part. This would be 5 2x plus 7 to the power half. Okay, this would be half, this would be 1 by 2 plus c. Now this can be written as 10, or we can cancel out this half and half. So I can write it down this as 5 2x plus 7 to the power half plus c. Okay, so we can also cross check our working, though this is not required in exam. Just for our understanding, we are doing this part. So if I have to differentiate this, what I would get is I should get the same function from where I started. Okay, let's differentiate. 5 is a constant, we can keep it outside. Now differentiation of this would be half comes in multiplication, 2x plus 7 half minus 1. Now differentiation of this is 2 plus c. Now this 2 and this 2 gets cancelled. Okay, sorry, differentiation of c is 0 over here. Now what we'll get is 5 2x plus 7 to the power half, negative half, which can be written as 5 upon 2x plus 7 to the power half, which is equivalent to 5 upon root over 2x plus 7. We started with the same function and we ended up. Okay, so I hope your idea is clear on this part. Okay, just to explain you the general formula for this same once more, I would write it down. Integration of ax plus b to the power n with respect to dx is ax plus b to the power n plus 1 whole divided by n plus 1 into 1 by a plus c. Clear? Thank you. I hope your idea on this concept is clear. Thank you so much.